Hi, welcome to the bada video lecture. In this session, we'll discuss the bada development environment. We're going to discuss the developer site, the bada SDK IDE, various development stages, and finally, selling your application. First, let's look at the developer site in detail. The bada developer site supports you in all stages of your application development. You can download the bada SDK from the bada developer site. To assist you in the development process, we have sample code, video tutorials, and blogs available here. Moreover, the bada forums opening on this site help you to discuss your issues with fellow developers. You can also create your application profiles and manifest XML files here. The first step to develop your application is to create the profile for your application on the developer site. For that, you need to log in to the developer site, http://developer.bada.com, and create your application profile. From the My Applications menu, select Application Manager. The My Applications page will be opened. On that page, you can see your already created application profiles. To start creating your new application profile, click on the Generate New Application Profile button. To create the profile, first you need to set a unique name for your application. Then, set the application description. This is optional. After that, click on Next. In this page, you can set your application version. Then select the bada API version. Based on the API versions, there's an option to select the device or application type. Since I've selected API version 2.0, we have the option to select the application type. You can select C++ app, Flash app, theme or web app based on your application type. Then, click on Generate to generate your application profile. In this screen, you can see your app ID and a button to continue. Clicking on that button will take you to the privilege selection page. On this page, you can select the API privileges required for your application. Once the selection is completed, you can click on Finish to complete the application profile creation. Now that you've completed creating the application profile, your manifest file is ready to download. Let's check some other options available on this page. On this page, you have the options to configure the server components, such as advertisements and content, etc. Also, there are options to set the bada test kit. The bada test kit provides you with a test environment to install and run multiple applications during the development process. Click on Download Manifest.xml to download the manifest file. Please note that the application profile creation or modification can be done at any stage of your app development. If you do it later, download the manifest file again and update it in your project to use it. Next, we'll discuss the bada SDK and IDE. You can download the SDK from the bada developer site and install it on your PC. Bada application development is based on the C++ programming language. As I mentioned earlier, the bada IDE is based on Eclipse, which makes it easier to use. Currently, the bada SDK can be used with operating systems such as Windows XP, Windows Vista, and Windows 7. The bada IDE is an integrated development environment that provides a set of development tools, such as a C++ editor, compiler, debugger, an application wizard for creating application projects, a UI builder for designing the application UI, a potential bug checker for tracing bugs in the source code, an API and privilege checker for checking API and privilege usage violations, a memory usage checker for monitoring the memory usage of an application, a profiler for optimizing application code, a JavaScript debugger for debugging web applications, a testing tool for unit testing, and a UI sequencer for testing the application UI. We'll discuss these topics in more detail later in the coding section. The bada IDE is based on the Eclipse CDT, the C/C++ development tools, and the JSDT, the JavaScript development tools. Eclipse provides a set of code editing tools with its text editor. These tools support CDT features such as syntax highlighting, code folding, tab documents, and content assistance, for example, context-sensitive code completion. The IDE UI consists of various views, which can be opened from Window, Show View, or Window, Show View, Other, bada. The most important bada-specific views are Output, Resource Explorer, Profile, and Problems. Now, let's see what each view does. The Output view shows the log, debug, and exception messages. The Resource Explorer shows the resources included in a project. It also allows you to easily add forms to your project. The Profile view shows a summary of the methods called during an application's execution, such as the call count and execution time. The Problems view shows build errors or warnings, and the results of the memory usage checker and API and privilege checker tools. Now, let's discuss the various application development stages and try to know what tools we have available in bada SDK, IDE to support these stages. We will discuss each stage in the application development, starting with designing. We'll then discuss coding, building your application, testing your application in the emulator or on the device, and finally, deployment. Now, let's look at how you can design your application's UI using the bada IDE. Samsung Bada provides a UI builder for designing and creating the application UI. The UI builder is a what you see is what you get design environment for creating user interfaces for applications. With the UI builder, you can create forms and all the user interface elements that you want the forms to contain. You can just drag and drop a control to the form to use it in the application. The UI Builder has a dedicated Properties section in the IDE that provides additional time-saving design options, such as zooming, setting the display to portrait or landscape mode, and aligning the controls. The UI Builder stores layout of the created forms as XML files into the project folder in the IDE. You can also use the UI Builder to create other kinds of application UI elements as separate resource files. For example, panels, pop-ups, and string tables can have their own resource XML files. To learn more about the UI Builder, you can check out the Advanced UI lecture. Now, let's explore the Project Explorer for an application sample. When you build your application, the execution files get stored in the binaries directory. You can have a look at all the included paths in the Includes folder. The Inc directory is used to hold header files, and the SRC directory stores all the source files. From the SRC directory, you can browse the elements of the C++ source files and open files in the editor view. The Home directory holds the readable and writable files and folders for the application. The Icons folder is used to store the application icons. The res directory is used to store the resource files, such as image and audio files, as well as the application UI layout files. You can access the application resources from the source code using /home and /res as the directory path. The application settings file, such as the manifest.xml and application.xml files, are stored in the root folder of the project. Next, let's browse the Resource Explorer for an application. This shows the resources of the selected application. If the Resource Explorer is not visible, you can open it up by selecting Window, Show View, Other, bada, Resource Explorer. You can check the forms, pop-ups, and other resources created through the UI Builder at this location. String tables holding multi-language compatible strings, which are useful for resource management and localization, can also be viewed and updated through the Resource Explorer. Now, let's discuss the coding stage. First, let's create a new project. For that, select File, New, bada C++, Flash Application Project in the IDE. You'll find the project types or templates such as a bada form-based application, a bada Flash-based application, and a bada empty project, and library templates such as a bada shared library and a bada static library. The bada form-based application template is suitable for creating a simple project based on a form. This template contains the basic application functionality, as well as the functionality for drawing a form on the device screen. The bada Flash-based application template is suitable for creating a simple project based on a Flash file. The template contains the basic application functionality, as well as the functionality for displaying the contents of a Flash file on the device screen. The bada empty project template is suitable for creating a project with project files only, without any source or include files. The template is used if you have existing source files that you want to import into a new project. The bada shared library template is suitable for creating shared libraries, and the bada static library template is suitable for creating static libraries. If you select a bada shared /static template, you need to make sure that the linker of the IDE can access the external libraries at build time. Therefore, you need to define the path to the libraries in the project settings. When you build the project, the IDE creates the links to the external static libraries. In addition, if you want to create a web application, you can go to IDE, File, New, bada Web Application Project, and create your project there. Note that in this lecture, we won't be going into the details of creating web applications. While creating the project, you can choose to use the default manifest file or the manifest file downloaded from the developer site. To use the downloaded file, you can browse and select the file while creating the project. Otherwise, the default will be used. Once you complete the project creation steps, all the folders and content we discussed in the Project Explorer section will be ready for you. Includes will show the bada platform, include files, and paths. The INC and SRC folders will contain the required initial source and header files. Home. This folder is used to store your application data, and this will be copied to the phone emulator. This folder can hold readable and writable files and folders for the application. The Icons folder contains the application icons, such as the main icon, splash image, etc. The Res folder holds the resource files, such as the image and audio files, as well as the application UI layout files, which can be edited with the UI Builder. Instead of the main.cpp file, we have an entry file in bada. As the name suggests, the entry.cpp file is the starting point of the application. When the user launches an application from the main menu, the first statements that are executed are located in the entry file. This means that everything that's required for the application to run needs to be referred to from the entry point, either directly or indirectly. The entry point for a bada C++ application is the OSP main method, which creates an instance of the application and executes it. The OSP main method is called by the bada operating system when the application is launched. The point to be noted here is that you can view this file, but you should not modify it. The manifest.xml and application.xml files are stored in the root folder of the project. Both files store various parameters of the application. All bada applications need to have a manifest file. After creating the application profile on the developer site, you can download the manifest file to be used in your application project. You don't need to create or edit the manifest file manually. The downloaded manifest file contains the relevant application information that you've defined in the application profile, or that has been generated based on the profile, such as the application ID, the application type, the assigned privilege groups, and the API version. If you choose to use the default manifest file during development, you can easily continue with it. Later, when it's time to submit the application, you can download and use the unique manifest file for your application. We'll discuss creating the application profile and downloading the manifest file in more detail later in this section. Using the UI Builder, you can generate the skeleton code for your application. To add event listeners for a button, right-click the button and select Add Event Handler. Select the listener to be added, enter an action ID in the Action ID field, and click Finish. If you need multiple event listeners, add them one at a time to be able to define an action ID separately for each one. The action IDs must be unique within a form. Also, you can configure the event handlers for each control. The event handler methods will be automatically created in your code. Now that we've looked at the coding section, let's look at how to build our application. First, let's look at how we can configure the build settings. To do that, you can select the project in the IDE, go to Properties, select Bada Build. You can select the application information and set your application icon, or set the model such as HVGA or WVGA here. Then, if you select application information, you get options to enable multitasking, export app control, etc. Next, build the application binaries for executing the code. Select the project in the Project Explorer. Set the build configuration to Release or Debug as per requirement, and then select Build Project in the right-click menu. After building the project successfully, you will get the executable binary. Up to this point, we've looked at how to design our application, implement the code, and build our application. Now we'll move to the testing part. You can test your application using the emulator, the remote test lab, or the real device. The device emulator, provided with the bada SDK, imitates the target environment running bada applications. Using this replicated environment, you can test your application before deploying it to the real target device. You can use the event injector to generate application events for debugging and testing purposes. The Remote Test Lab, or RTL, allows you to install and test applications on supported bada devices over the web using an RTL Eclipse plugin installed in the bada IDE. You can run an application on the target device using the Project Explorer or the bada IDE menu. Right-click the project in the Project Explorer and select Run as Run Configurations. Select the configuration you're going to test. The bada IDE also provides several tools to test your application. The bada UI sequencer tool can be used to test the application UI. This involves recording a sequence of user events and being able to play the same event sequence on the same or later versions of the application. The unit testing tool detects and fixes code defects in each unit and thus improves the overall performance of the software. There's a code coverage tool that's part of the testing tool, and it checks how comprehensively an application has been tested. You can monitor the memory used by your application using the Memory Usage Checker. The performance of your application can be traced on the target device or emulator using the Performance Analyzer tool available with the bada SDK. In addition to this, you can analyze the application execution on the target device or emulator using the Profiler tool, which is available in the bada IDE. Now, let's look at the emulator option in detail. The emulator emulates the target device to run bada applications. It enables you to use a target device optimized environment to debug and test your application on your local machine before deploying it to the real target device. The emulator uses native debuggers that enable you to control your application's execution. This figure illustrates the emulator control keys and the emulator menu, which lets you easily control the emulator environment. You have a camera key, an end key, a home key, and side up and down keys in the emulator, which allow you to easily check the key events in your application. To access the menu options, you need to right-click on the emulator. Next, let's look into the menu options. The first option is the Event Injector. To open the Event Injector, right-click the emulator and select Event Injector. The Event Injector lets you artificially create and use any data you need. You can even imitate environmental conditions for device sensors. Let's look in detail what all can be done with the Event Injector. It can simulate incoming calls. From the Network tab, you can send Network Select Information indication. In the Messaging tab, we get the options to simulate incoming SMS messages, status reports, and push messaging. For location applications, we can inject location data into the application. We can simulate device sensors, such as the acceleration, magnetic, tilt, and proximity sensors. In the Device tab are options to set the battery level, memory, such as USB devices, MMC, etc., the ear mic, and RSSI information. For NFC, we can simulate NFC tag detection, NDF events, and plain tag connection with event injectors. The rotate option in the emulator simulates the change in modes. For example, switching between portrait and landscape modes if the application supports rotation. The error lookup option retrieves a system error message based on the entered error value. The Update Content DB option registers newly added data files, such as images, sounds, videos, or other media data in the media directory, which emulates mass storage mode, or in the MMC directory, which emulates multimedia card storage. The point to be noted here is that this option works only on an idle screen. Then, if you browse through the Options item, you can adjust the emulator size with the Size option and set the emulator on top of other desktop windows with the Always on Top option. In addition to these, you have an option to save the screenshot of the emulator screen as an image file or to the clipboard using Save to File and Copy to Clipboard, respectively. Then, to shut down the emulator, you can use the Close option. Next, let's discuss how to test applications on the device. You can test your application on the target device using RTL or directly with the device. With the Remote Test Lab client, you can control the remote device you have reserved and use it to run your applications. To use the RTL client, you must be logged into the RTL server. To use the RTL system and client, you must install the RTL plugin in your bada IDE. All bada members can use the RTL service for free by reserving a time slot to test their application. You can run an application on the target device using the Project Explorer or the bada IDE menu. To run your application on a target device, you need to first connect the target device to your computer. Then, configure the target device to run applications on it. We can start running the application either by right-clicking the project in the Project Explorer and selecting Run As Bada Target Application, or in the bada IDE menu by going to Run As Bada Target Application. The executable binary, resource files, and data files are downloaded before starting the run, and the application is installed automatically while it runs. While the application is running, the IDE's output view shows the log, debug, and exception messages from the methods defined in the log macros. To terminate the run, you also have multiple options. From the bada IDE, you can terminate the application by clicking on the Terminate button in the console or debug view. On the target device, you can press the End key to terminate the application. Once the testing's done, we can disconnect the target device. As discussed earlier, the bada SDK has various tools to support the development and testing of processes. First, let's talk about the UI sequencer. You can use the UI sequencer tool for various purposes during development and testing. During the development, you can record tedious and repetitive user event sequences, such as login processes. You can then play the recordings whenever you're using the application to avoid having to perform the user events manually every time you want to check something by running the application. In regression testing, you can compare the screens displayed on the current application UI with the screens that were previously recorded from an earlier application version. The comparison allows you to test whether the user events continue to result in expected changes in the UI, regardless of the changes made in the application. In stress testing, you can set the tool to run the same user event sequences repeatedly for a defined number of times. Another tool available to assist with the development is the unit testing tool. The bada IDE provides a tool for unit testing bada applications. The bada testing tool provides two options for unit testing. First, the wizard configures the unit testing environment and generates method stubs to test the behavior of the application code. Then, the OSP test namespace provides an API that enables you to develop different types of test cases. Using this, you can run selected test cases and view the test results on the same screen. You can also import or export test results in the form of XML files. The diagram here illustrates the results for a test project. The testing tool also contains a code coverage tool. This tool uses the gcov test coverage program. This program supports line coverage, which indicates the percentage of the lines of code executed. It's shown in the code coverage graph. This tool can be enabled in the Project, Properties, bada coverage compile option. You can monitor the memory used by your application using the memory usage checker. This option can be enabled in Project, Run As, Run Configurations, Check Memory Usage. A memory usage report is generated while the application is running on the emulator, and the generated report is displayed in the Problems view after the application's terminated. The figure shows an example of a memory usage report, which includes the memory leakage, incorrect memory usage, and memory profiling. The Performance Analyzer provides monitors to trace the usage of various application resources, such as databases, files, and memory, and displays the tracing results. While tracing, and afterwards when viewing the trace files, the tool offers multiple views for monitoring the application performance. The figure illustrates the views supported by the Performance Analyzer. You can analyze the application execution on the target device or emulator using the Profiler tool, which is available in the bada IDE. The Profiler calculates the application method call count and execution time and determines the code fragments that take the maximum time to execute. This information further helps you to optimize your application code by identifying the bottlenecks in the code blocks. To use the profiler, you must first set the profiling options of the application, and then run the application on the target device or emulator. The profiling results are displayed on the profile view of the IDE after the run. The diagram shows the profile including hotspots and the call graph. We've reached the final stage of development, the deployment stage. If you've been using the default manifest file for your development, download the new one from the developer site and build and test your application with it. Once this is done, go to the Project menu and click on the Make Package option. This will create the package with application binaries, resources, manifest, and application.xml files. This package can be submitted on the seller site. Now, let's look at how to sell your app. The seller site is the place where you can upload and sell your apps. You can register your application here, get it certified, and once it's for sale, you can manage your sales as well. The applications on sale will be available on the Samsung Apps website. ODC, the on-device client, is a sales channel for applications on the handset. Users can search for applications and purchase and download them using the on-device client. There are 6 steps to submit applications to the seller site. The first step is Overview. This step contains basic elements for selling applications, such as an icon image, screenshots, and supported languages. The second step is sales information. In this step, sellers need to decide how to pay and where to sell. In the next step, sellers should select the supported OS and device. In the fourth step, sellers can finally upload their application binaries. Moving on to the next step, all the information the seller entered is double-checked. If there's no problem with the information, the registration process is completed. There's a communications channel with reviewers, which is called the Comments to the Apps Review Board. When you submit your application, you may describe any references which the reviewers should refer to. This information is very helpful to reviewers to reduce their review time. And it's helpful to developers as well. App certification is a process that determines if the application is appropriate for Samsung apps. It makes sure that the end user gets a quality app that runs on a Samsung phone without any problems. We have a 3-step certification flow: the content review, device test, and confirmation steps. We do our best to complete this process within 7 business days. Immediately after you submit your application, we review if your application contains any banned content based on our content review criteria. If your application passes this phase, your application will be device tested, checking its usability and compatibility, such as interrupting or using HW keys. In the confirmation phase, reviewers will finally decide whether or not to pass the application. We provide many marketing options to boost sellers' promotional opportunities. One option is to add banners. Sellers can request posting their own application banners on the storefront. Then, sellers can lower their price directly by using the discount menu. In addition to these, different events are organized by Samsung, such as developer challenges, which can be used by sellers to promote their apps. Now that we've reached the end of the session, let's look at what we've learned so far. First, we had an overview of the support available on the developer site. Then, we learned about the bada IDE and SDK and had a walkthrough of the different steps of the bada application development. Finally, we saw how to submit our apps on the seller site and how to promote them.